Welcome, everyone, to our NACDA Data on Aging podcast series. Thank you for being here. Today, we are going to talk with Dr. Arun Balachandran, and he has been involved with the India Human Development Survey, which we have on our ICPSR sites. He's also a postdoctoral research scientist at the Robert N. Butler Columbia Aging Center, Columbia University Mailman School of Public Health. His research focus, it really intersects across population aging, quantitative methodology, and public health. He's worked with the University of Maryland, College Park, and with the Population Council, involved with the design and implementation of a unique longitudinal database in the Global South, as I mentioned, the India Human Development Survey, IHDS. It's the only nationally representative longitudinal survey on social health and development indicators. So we're looking forward to talking with him about that. And he's currently working on new measures to population aging using longitudinal biomarker data. His most recent study is Pace of Aging Analysis of Healthspan and Lifespan in Older Adults in the US and UK, and he was featured in Nature Aging just this May. And we are very excited to talk with him. So it's pretty great, and we're going to jump into our questions. So, Dr. Balachandran, why don't you talk about how you got involved with your research?
Thank you, Catherine, for the grand introduction and for the invite. As you mentioned, I worked earlier with the India Human Development Survey, but I'm originally from India and I belong to this province in India called Kerala. So when we think about India, we have a demographically young population, whereas Kerala it's also a slightly advanced in its demographic transition that it has higher share of elderly. So in Kerala, we have around 17% of share of elderly versus around 10% nationally. So I was always interested in population aging per se, but once I joined PhD with a particular interest in human capital, I joined for my PhD in economics at the Institute for Social and Economic Change in India. And my supervisor, Professor K.S. James, was involved with a project with University of Groningen with Professor Ajay Bailey. That project was titled Age Globe Project, which really looked at aging from a global scale. And then I combined my interest in aging and human capital with the interest of the project of global aging. And thus, I started working on aging after adjusting for human capital and health. And so that's how the chronology of my work started and my interest went.
That sounds really cool. It's interesting that you were sort of always interested in aging and, societal constructs around aging. Some people we talk to kind of go there through uh, a less linear path. So yeah, that's really cool. So what, why don't you talk about some of the central objectives of your recent work?
Yeah. Definitely. So I was always interested, but my work really started taking shape once my supervisors, my co-collaborators started getting involved, and then I kind of understood this whole field and the great works that's happening in this field. I'm a demographer by training, so particularly in the population aging sphere, and I understood that there is this drastic changes with respect to population aging methodology that's happening in the last almost 2 decades in population aging research. So one of the particular, there are several changes that's happening in the methodology, but one very important and prominent methodology is to recalculate aging, old age or old age threshold value based on certain demographics, certain biological factors, etc. So for instance, my own earlier work is on to understand, okay, if 65 is the particular old age threshold in one country, what is, say, a benchmark country like Japan, what is the equivalent old age values across other countries, and then people are also working on what's called biological aging, etc. Now, once I started my recent work, I realized that there's always this new measures that is looking beyond chronological ages, say for instance the biological aging measure. But what it does not do is that the existing cross-sectional measurements, often because of the data availability, they fail to separate aging uh, aging from age, or separate aging related changes in early life differences with what happening right now. So rather than reversing early age disadvantages or genetic differences or early age nutritional differences, the interventions, to understand what is the faster, is it a faster or slower current aging is not understood, and this differentiation is not made, and hence that differentiation kind of allows for this distinction in terms of intervention. So if you know if the current aging is faster or slower, that makes it better for intervention rather than knowing the overall life course value. So for example, when you know the biological age is 67, we do not know if it is due to early life factors or is it due to current changes happening in the human body. So that is exactly what I do in my current research, where I differentiate what happening early in life with the current happenings in life. So which means I formulate what is called as an adapted pace of aging method for population aging, population studies of older adults. And this is actually an extension of a previous method by my supervisor, Dr. Dan Belsky. He propounded a pace of aging method for a certain clinical set of people in the Dunedin study. So I took up this method for a population level understanding to expand this to what is called as adapted pace of aging method to measure the rate of age-related decline in individuals using a longitudinal data longitudinal data from multiple organ systems.
Wow. So I've heard a little bit about this kind of work where there's how old we are, like you said, chronologically, and then there's how old maybe our body tells us we are. And then it's interesting because then you could maybe also ask people how old do they feel? Um, and so can I ask where is it like where is the information coming from? Like how geographically focused is it?
Sure. So as I was mentioning, I was interested in a global measure.
Yeah.
Uh,
Yeah.
and thus, if you globally ask how old are you,
Mm,
that is a subjective question which could have different connotations across different parts of the world. So
mhm,
we wanted to look at a little more objective way of looking at it, and demographers are often turning to biomarkers for these objective kind of information. So what we did in the modified pace of aging method, in this adapted method, is that we developed it using nationally representative longitudinal studies, which has follow-ups. So, for example, the US Health and Retirement Study and the English longitudinal study has biomarker data and the follow-up of these people. And so, what we did is we developed this method from the physical assessment, the functional test, performance data, and the blood biomarker data. To be specific, we had 9 different biomarkers, 3 blood biomarkers, HbA1c, CRP, and cystatin C, 3
mm,
physical assessments, diastolic blood pressure, lung function, and waist circumference, and 3 functional tests, which are gait, speed, balance, and grip strength. And we used a combination of these 9 different biomarker measures to combine it to adjust for the cohort effects of it, and then to predict the values for. So as you know, this is information for people above age 50, and then we chose participants. The participants are surveyed once in every 4 years, and we chose around we chose those individuals who at least had 2 repeated measures for at least of the 6 of the different biomarkers we selected, and that's around 14,000 individuals in the health and retirement study in US, and around 6,000 individuals in the UK ELSA study. And for this, around this 19,000 to 20,000 people, we looked at this 9 different biomarkers and then found out a combined measure, what's called a pace of aging, which looks at the longitudinal decline in different system integrity of individuals.
sounds really cool. It sounds like a lot of work too. And you've kind of started to, well, you've talked about the how a bit. And so why don't you talk about some of your major findings?
Sure. So once we found the space of aging, our particular interest was to understand how does it change by groups, how does it change by countries, by several subgroups within countries. So what we found is that pace of aging is highly variable in older adults in the US and UK. People who are older at the baseline, when we started looking at them, they were having faster pace of aging, and this is consistent with several of the prior observations. Population groups that have shorter lifespans, say for example people with lower levels of education, they have a faster pace of aging. Older adults with faster pace of aging were more likely to accumulate, and this is, I think, a very important aspect of our study, because we looked at pace of aging and then how it changes by subgroups, but then we looked at the later data. So we had data from say 2006 to 16, but post 2016, does pace of aging kind of kind of predict how their incident mortality and morbidity occurs. So this is exactly what we find, that older adults with faster pace of aging were more likely to develop new chronic diseases over follow-up, were more likely to be disabled, were more likely to be cognitively impaired, and were more likely to be likely to develop dementia. They were also more likely to die. So which means the strength of these associations were similar to several other measures of biological age, but it's actually often bigger than the existing measures of biological age. So the longitudinal biomarker, biological age measure, like what we found, has a higher strength in predicting the incident mortality and morbidity among individuals in their future years.
Yeah, yeah, that makes a lot of sense. Um, yeah, I can think of some, uh, it's kind of a silly pop culture reference. There was a Simpsons episode about Flanders and Homer Simpson, and you know, basically everybody finds out Flanders is like 50 or something, but he looks actually very young, and it's because he's not had a lot of exposure to I don't know, life events like major sicknesses, or put himself in risky situations to pose health issues. Anyway,
Yeah,
that's
yeah. I
what
mean,
you just reminded me of.
I remember another reference that when Nadal won his U.S. Open, I mean, one of the major Grand Slams, he mentioned that he was 35, and he said that 35 is the new 25, and and similarly, maybe 60, 65
Oh,
is
wow.
only the new 45 or 50. So
And what is that going to mean for retirement? You know what I mean?
yeah, yeah.
If like 65 is the new 55 or 35 is the new 25. Yeah. Wow.
Yeah, no, it's not just the implications are not just for really retirement, because if you look at why population aging is happening, it's due to two things, and one is that the fertility is going down, which
Yeah.
means number of children across the world are going down, irrespective of where you are, US, UK, or even if it is say Africa. The fertility
Yeah.
has been going down. In India, for instance, the fertility is today below replacement level, and for a large country like India, we would not expect that. But then the life expectancy has been going up in the last 5 to 7 decades across the world. So when that two demographic phenomenon happen simultaneously, then what we traditionally know as population aging, which is the rise in people above age 65, is going up, and this is a straightforward demographic
Yeah.
transition. But the impact is not just for retirement, because the number of people entering the labor market is also going to go down. But the impact is also for generally for disability related studies, or governments planning for older
Yeah.
population, disabled population, etc. So, but in general, I also want to highlight this, that pace of aging method, the adapted pace of aging method, what it also means is that this is like, what we do here is like a template with US and UK data, but this is really a methodology that can be really replicated based on replicated to other countries. And we already know, like you particularly know about the other data sets like HRS and ELSA. For instance, globally there are these sister surveys of HRS. So
Right.
once they have the follow-up data, this is actually a what we see is that this is a template that can be replicated to understand pace of aging across countries. But it also has implications not just for, say, biodemographic studies, but also, say, for example, sociology or economics, like you said about retirement and stuff like that. So the pace of aging measure kind of potentially supports diverse research areas such as, say, sociology and economics can explore. For example, they can explore how social factors affect healthy aging. Medicine and gerontology can look at the impact of health events on aging. Life course epidemiology can look at, say, distinguish early life influences from the existing health issues. Health equity studies, for example, can identify disparities and the effect of economic shocks or health shocks on pace of aging. So these insights from pace of aging analysis can support monitoring populations to observe trends in healthy longevity and assist in identifying policies and social programs to promote healthy lifespan among both individuals and groups, and who are not. So the idea is that often in survey data we have measurement of morbidity as, say, ADL, IADL, etc., right? But here we can actually have a measure which looks at morbidity for people who are not yet developed a chronic condition, but who are potentially in the prospect of developing this. So I want to highlight that pace of aging is a biodemographic measure, but it kind of have an impact globally, but also as
Of course.
across other disciplines in social science.
Thank you so much. Yes, it is huge. There's individual impact and there's population impact, and as you said, societal impact, because we have to plan for these population changes for sure. Um, so what are some of the challenges of the research process for you with these, major longitudinal studies and working these comparisons across them?
Yeah, sure. I mean, this is definitely a lot of longitudinal data analysis and clearly a challenging work in that sense. But one particular, at a starting point, the challenges was that I wanted to develop a global pace of aging measure, but the follow-up data, the longitudinal data availability was only currently available for 2 countries. I know that several other countries are also starting to develop this. Maybe in future it's available. So the longitudinal data availability was the primary, starting point, challenge to start with. But then also I found that there are these sparse measurements of biomarkers in large nationally representative studies, and so there are several studies which are starting to look at biomarkers, but I think uh, uh, in general I found few studies with follow-ups on biomarker follow-ups, and thus that was another challenge. Having only 3 repeated measurements prevented identification of non-linear patterns. So what I believe that the results that I have on pace of aging are actually kind of conservative, because these groups that are at the highest risk, are already at the risk of say, onset of morbidity and mortality, and thus they are probably underrepresented in my sample, which means
Yeah.
that so the availability of a longitudinal measures, availability of representative longitudinal measure was something that is particularly challenging for me, and this is also something I found in the review process. So for example, when I submit this to a journal, these are the kind of questions that comes back to me, and so the review process really went long. But I'm happy to inform you that a couple of weeks back this is accepted in Nature Aging, and so if any of you are interested in learning more about this work, look at the Nature Aging articles in the end of May.
That is very cool. Yeah, definitely exciting and something you want to promote. So, what advice would you give to other researchers trying to use longitudinal data in the same way, or other people trying to use what you've created, this design that to replicate this kind of research?
Yeah. So to replicate the codes are available in GitHub, and if you request us the data, also we can data and the codes we can share. But in general, with respect to longitudinal data and survey data, what we find is that in a supplement of our article, we have the association of this longitudinal pace of aging with with that of the cross-sectional biological age measures, and we look at how these associations differ with respect to the incident morbidity, incident mortality, and incident cognitive decline and dementia. So what we find is that this longitudinal data, the longitudinal data based measure pace of aging, is actually better at predicting these associations on incidence, morbidity, mortality, and cognitive decline, right? So which means that longitudinal data gives a little more insight into understanding aging and population aging in particular than what the cross-sectional data generally can give. And this is a direction for a future impactful research. So while as researchers, what we should remember probably is that there would be limitations with data availability and computational knowledge and computations with respect to longitudinal data, but it is I mean, I learned, and I think it should be good to keep in mind that a small step towards understanding this longitudinal data based approach and solutions could in turn be a leap in a long run of understanding social and aging related aging related aspects. So that's what I want to highlight, which is that a small step towards longitudinal data based solutions could in turn be a leap in the long run, and this is particularly true for population level studies in longitudinal research.
Thank you. Yes, that makes a lot of sense. And you know, a lot of things in life are like that, where a few people have to start something in order for it to catch on, and then it grows. And so yeah, this is really interesting. And I think we kind of naturally segue into the next kind of question, because you're talking about, paving the way for future work. And you've talked about the collaborations that have, benefited you. And so I like to ask, what kind of conferences or meetings do you attend, or if there are networks you're involved in? Is there anything you'd recommend to other people?
So, I mean, I was fortunate to attend several of the conferences across several disciplines. For example, the Population Association of America conference for which are more demographers. There are these GSA, the Gerontological Society of America conferences, which is really an interdisciplinary crowd. But I was also fortunate to attend, say, the international conferences such as IUSSP, the International Union for Scientific Study of Population conferences, some of the economic conferences. So what I learned in general is that aging and pace of aging generally has a lot of insights for each field, but I also learn a lot from discussing with people from these multiple disciplines. And I think the priorities that different disciplines and different researchers give us is kind of exciting to expand our existing method, and to to look at broadly at the societal implications for aging and pace of aging. So this is, for example, one of the things that I'm excited right now is to look at the to generate knowledge about what drives pace of aging across, and what drives these differences in population healthy longevity. For example, understanding what are the drivers that that leads to different pace of aging across different socioeconomic groups and different countries is something that I'm very excited to look now. For example, there are these public health priorities related to air pollution, related to rise in temperature, related to, say, differences in climate vulnerability, etc. So I'm really excited to look at, see if air pollution or rise in temperature kind of poses a significant threat to aging population, and does it kind of bring a difference in pace of aging if you live in a place with lower air pollution vis-a-vis with a place with higher air pollution, or does it kind of accelerate your pace of aging if the temperature rises in the area that you live in the country that you live in, etc. So these are the kind of questions that I'm interested to look at now, and this particularly comes from my exposure to people from different different disciplines. And I think from a longitudinal data point of view, if you can link longitudinal biomarker data with small area air pollution data or heat data, we can kind of explore association between, say, air pollution or heat exposure with pace of aging, and thus it can give a longitudinal measure of decline in physical and physiological decline in addition to what we have, which are cross sectional. And as I mentioned earlier, the longitudinal measure would give much more impact much more insight into understanding the aging scenario, and such impactful associations to drive policy making both in the US and in countries across the world is what is currently exciting me as a researcher, and this is what I'm looking forward for the future.
You. Yeah, that's wonderful. I know that there's the Center for Aging, Climate and Health. Its acronym is CASH, and I think that they're a group of people interested in some of the same things that you were talking about, that excites you. That combination of, you know, research on aging and climate issues such as air pollution, and a number of other things. And so, yeah. And they've been involved at some of the same conferences you mentioned, like the Gerontological Society of America. And I mean, I say this to almost everybody who brings this up, but I hope we see you at GSA this year because we often have a booth. So I hope you'll stop by and say hello.
Yeah, definitely. I look forward to that. Thank you, Catherine, for the wonderful meeting, and I really enjoyed this.
Thank you. I enjoyed it too. It's so nice to talk with you and learn about how you're using HRS and ELSA and just hear about, how you've got to where you are in your Nature Aging article. And yeah, just the pace of aging. It sounds really interesting and like it's going to be really valuable, especially as, as you said, as the population um, continues to get older and we need different things to accommodate that. Is there anything else you wanted to talk about? Anything else that you're excited about with respect to being a researcher now, or any last things you want
Uh,
to mention?
yeah, I mean, so IHDS, for example, the India Human Development Survey, which I was involved with at the University of Maryland, which is under the wonderful supervision of Professor Sonalde Desai, is actually one of its kind, particularly because it is kind of a rare nationally longitudinal, nationally representative longitudinal data in a global south country, in this case in India. So there are very few instances of nationally representative longitudinal study in countries of global south, and this is particularly what we see when we explore these large questions related to, say, a new methodology such as space of aging across the world. And thus we see this, and thus so I'm really proud and want to thank Sonal for doing the IHDS data, and that is one line of thought and one line of extension of research that I'm doing, which is to look at the several of the questions related to aging, social, economic, and epidemiological impacts, and use IHDS data to understand this. And the third wave of IHDS, mind you, this is a country like India where it is really large and nationally representative, means brings a lot of complications in terms of how to follow up people, etc. And IHDS has, for the last two rounds, a kind of a pretty good, relatively good follow-up, and so we are excited to have the third round of IHDS kind of prepare. It's the preparation is on the way and it's ready to be kind of out soon. So that is one line of research that I think any demographer, any social scientist would love to take up, to look at all the methodological and the hypothesis that we bring from a methodological point of view to an empirical point of view using IHDS, and look at it for countries in global south, for India in particular. And this is also a line of thought and research that I'm extensively planning to use in my 3 to 5 years ahead.
That sounds great. Yes, it's such good news to hear that the third wave of IHDS is in progress, and that hopefully we'll see it soon, available for download. And yeah, it's great that you're involved with that work.
Yeah. It's a
Cool.
wonderful work.
Well, thank you so much for joining us today. And it's been a great conversation. And please do, keep us posted about, any new things you get involved with. Yeah.
Thank you, Catherine. It's wonderful to have this talk, and thanks Urvashi and Catherine for reaching out.
Thank you so much to our guest and to our listeners for joining us on this podcast. You can find links to studies we referenced by viewing the description and content below. If you have questions or ideas, please email us at icpsr-nacda@umich.edu.